Hi, welcome back to Maths Masters. This is the review of previous learning session, so the RPL session, and this is where we're going to go back and look over all the addition sessions we've done up to now. So looking back at addition 1 to 4. I'll give you some activities to practice so you can pause and have a go at those, and we'll work through those together. And then at the end of the session, if you click on the description at the bottom of the video, there should be an arrow, and in there there's an activity for you to print out or pull up on your screen and have a go at practicing those yourself. Use concrete materials, use objects, use counters, use base 10, use pictorial, or do it abstract. It's up to you. So remember that the struggle, the practice, will help you to build on your learning. So you've got to learn, practice, and then master. So any of these things, if you find at the end of the session that you're still struggling with something, keep practicing that. You're aiming for about 80% success rate. So getting about 7, 8 out of 10 answers correct. So if you're struggling with it, practice until you're able to get to that. So the first thing that we looked at in session 1 is adding one more. So you can use a tens frame like that, or you can have a tens frame broken up, cut up into sections like that. And we looked at using Lego people in the first section, but you can use counters, you can use different objects, you can use cubes. So if we have the number sentence 4 add 1, then we can make it, so I'm going to have a go using counters. We can start with 4. Okay, we know we've got 4 there, and we can add one more. How many have we got now? So we can use a blue count and then use a green one to show that's the one more we've added on. We can know there are 4, add one more is 5, or count them 1, 2, 3. So we can count them 1, 2, 3, 4, 5 all together. And we can write that as a number sentence. 4 add 1 is equal to 5. Some of you have been having a go at counting one more, finding one more than bigger numbers. So you might have things like 84 add 1. So you can practice this by using number lines. You can print out 100 square, or just practice counting on forwards and backwards in our number system. 84 add one more is 85. Okay, so the next thing we looked at is using the Pothole Model. Okay, so this is the Pothole Model, a really useful model to help us to break up numbers, to find numbers that combine together to add, to find missing parts when we're doing our addition. So which is the part? Well, the part, have a think about that for a moment. Which is the part? Okay, so I'm hoping you thought that the part is the 2 and the 7. They're the parts that combine together to make the whole. So here we have the whole one. So when we combine the 2 and the 7, when we add those two together, what whole do we make? What whole number do we make together when we combine those together? So we've got 2 add 7 is equal to 9. So you can use counters, you can use objects in the Pothole Model, combine them together and then count them. If you need to move them up there and then count them, do that. Which Pothole Model represents 4 add 2 is equal to 6? Have a look at that. Which Pothole Model is representing that number sentence? Okay, so the first one, the whole is 2. and the parts are 6 and 4. 6 and 4 combined doesn't make 2, so that one doesn't work here. The whole here is 2 again. We've got 4 and 6 as the parts that combine together, add together to make 2, so that one doesn't work. Here we've got the whole is 6, 4 and 2 are the parts, so 4 and 2 combine together to make 6. There'll be lots of chance for you to practice the Pothole model and finding one more in the activity sheet. The next thing we looked at in session 2 was finding fact families, and we were looking at addition fact families. So these are number sentences using 3 numbers to combine groups to make addition sentences. So what fact family, which 4 number sentences can we make out of this addition? Pause this and have a go. Okay, so I'm hoping that you found there were 5 here and 4 here. So we're adding together 5 and 4. So 5 add 4 is equal to, so you could count both the groups together to find how many there are in total, or start at 5 and add on 6, 7, 8, 9. So there were 9. We could have added them the other way round. 4 add 9. Sorry, 4 add 5. 4 add 5. Let's check it. 4, 5, 6, 7, 8, 9 is equal to 9. Because we learned this in these sessions that addition is commutative, so that it can be done, the parts can be added in any order. We will get the same answer. It doesn't matter which order we add the parts together. Okay, so something is equal to something and something. Okay, so we've got all together, we have got 9 fish, which is equal to, 9 fish is equal to the parts 5 and 4. We can also say it the other way, 9 fish is equal to the parts 4 and 5. So we've got our 4 addition fact families there. Try this one. Pause this and have a go at that one. Okay, so this time you've got 2 and add 3 that you're adding together. So we can have 2 add 3 combined together, added together is equal to 2, 3, 4, 5 is equal to 5. We can do the number sentence the other way around. We can start with 3. 3, add 2 more. 3, 4, 5 is equal to 5. We've got 5 all together in total. Those 5 we've got is equal to 2 add 3. And the 5 we have in total that we have all together is equal to 3 and 2. So we found our fact families there. Have a practice of those on the activity sheet. The next thing we looked at are number bonds. Number bonds that are 2 numbers that go together to make another number, and it's really useful to know your number bonds off by heart because it will help you later when you come to do mental and written addition if you can quickly retrieve this information from memory without having to add them on. So we've got some spots, so we need to know how many spots there are first. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. How many different ways can you place the spots on the balls? So, somebody here has started working it out. Okay, what's the problem with this way of working it out? Hopefully, you've thought about the fact that yes, you can work it out by randomly placing the spots on the 2 different balls, but if you work systematically, you make sure you cover all possibilities. So what you need to do is think about working in a systematic way. So what I would do is I'd put 0 on that ball and 10 on the other one. Then I'd put 1 on that one and 9 on the other. 2 and 8, 3 and 7 on the other one, 4 and 6. I could have 5 and 5 on each of them. And then I could do it the other way around. I could have 6 on the first one and 4 on the second. Then I could have, well, I've already used 5 and 5, so I won't be able to use that one again. 7 and 3. I could have 8 on this one and 2 on the second one. I could have 9 on this one and 1 on the second one. Then I have 10 on the first one and 0 on the second one. And by doing it that way, I've made sure that I found all possibilities. I'm working up one each time. Then when I got to where I'd split them in half exactly, I changed it over. So then I put 6 onto this one. So I've made sure that this ball has had every possible amount of dots, of spots placed on it. Okay, there are some number bond activities for you to do in the activity section. The next thing we looked at was adding by counting on. So this is not adding all, this is starting at the number and adding on more. So have a go at this one. Okay, so you could use a number line. So you could have start at 8 and add on 3 more. So 8, 9, 10, 11. So I've counted on 3 more and it makes 11. So remember, you're not counting all, you're starting at the number. And because we talked about that commutative property of addition, that it can be done in any order, it's great to start with the biggest number. A problem here, Katie has 7p in her pocket. She adds 5p more. How much has she in total? So we've got 7p in the pocket, and then we need to add on 5p more. So you can use objects, you can use a number line to count on, you can use counters, or you can just count on in your head. So 7p, so have a go at that one. Okay, so 7p, add on 5 more. So we could add this on a number line. 8, 9, 10, 11. So we've gone, going to get rid of that. So we start at 8 and we want to add on 5 more. 1, 2, 3, 4, 5. But what you would need to do in this way is count from 7, 7, 8, 9, 10, 11, 12. So we know we've added on 5 more. That's why it's really useful to use your fingers as well for these things. If you've got 7, you put 7 in your head and count on 8, 9, 10, 11, 12. You must make sure that the next number you count on when you do that, so if you put 7 in your head, when you count on the 5 more, make sure that you count the next number. So if we've got 7 in your head, you don't want to then say 7 in your head, 7, 8, 9, 10, 11. You must make sure you jump on and move forward to the next number. So it goes 7, 8, 9, 10, 11, 12. The final thing that we looked at, actually before we go on to that, I had some brilliant work sent in to me and a number puzzle. There were 2,789 animals in the zoo. 6 monkeys were born. How many animals are in the zoo now? So that's something a little bit more challenging. If you want to, have a go at that one. So 2,789 add 6 makes 2,795. Okay. The final thing that we worked on this week is regrouping and adding to make 10. This is so useful for later addition, and I'll show you an example of this. If I was doing the number sentence that we just did then, which was 2,789 add 6, what I would do is split that into 1 and 5, because 9 and 1 makes 10. So then I know I've got 2,790 and just add the 5 on, so it's 2,795. So I can do it really quickly in my head without having to count on 6. So I don't have to go 2,789, add 6, 2,790, 2,791. I can just split the number, partition it in my head, and regroup to make it into a 10. Okay, so in the activity section, there is a little prompt in there with little steps that you can take to help you to work through the approach of adding by making 10. Or we call that regrouping. So regrouping those numbers. So the first thing you need to do is start with the bigger number. So if we start with 7, add 5, one useful way to begin to see this is using a tens frame. So we can start with 7, and we get 7 counters and place those on. 1, 2, 3, 4, 5, 6, 7, and I need to add 5 more. So I'm going to partition the 5 because I'm going to make it up to 10 first. I'm going to regroup this number to make it into 10. So I've got 3 spaces there. So what I'm going to do with 5 is break it up, partition it into 3, because 7 and 3 make 10. And then I've got of the 5 that I have to add, I've got 2 more that I need to add. So I break 5 up into 3 and 2, and then I have 10 and 2 more, which is 12. So this would look like 7 add 5 is equal to 7, add 3, add 2 is equal to 12. Now try one yourself. So, try this one. 9 add 4. So start off with 9 counters. You need to check there's 9, count them, so 9. How are you going to partition the 4 to regroup it, to add it to make 10 first, then what have you got left, and then add them all together? Pause me and have a go at that. Okay, so starting with 9, now with this we can add 1 there, so we can break 4 into 1, because 9 and 1, we know our number bonds to 10 by now, 9 and 1 is equal to 10. Then we can place the 3 more, so partition 4 into 1 and 3, so we've got 9 is add 4 is equal to 9 add 1 add 3 is equal to 13, because we've got 10 and 3, which makes 13. Final problem for today. Andy wants to add 2 numbers by regrouping or to make 10. He wants to add the numbers 7 and 6. Susan offers these examples of how he could do it. 7 add 6. Okay, so which one is the most helpful to Andy to be able to add these numbers? Have a look at that. Okay, so 7 and 6. So here, 6 has been partitioned into 2 and 4. This isn't really useful for us here because 7 and 2 makes 9. We want to be able to combine, to regroup this number here to make 10, for us to be able to get to the nearest 10. So that isn't helpful. This one, the 7 has been partitioned into 3 and 3. So that just isn't helpful because we're adding the 6 on. This one here, the 6 has been partitioned into 3 and 3. 7 and 3 makes 10. Add on 3 more makes 13. So that one works. And if we look at it here, 7 and 3, if we partition that, and we add on our 3 more, makes 13. The final one here, we've got 7 and 6, partitioned into 6 and 0. 7 and 6 isn't helpful, so this one doesn't work either. Okay, so remember, have a go at the activity section, keep practicing, that will really help you to master the skill. If you want, you can make some examples of your own to practice these and keep having a go. The practice will pay off, I can assure you. Okay, don't forget to subscribe, share any work you've done with me, and I'll see you in the next session. Thank you, bye.